So now we're going to talk a little bit about symmetry. Something is said to have symmetry if it matches up. So when you think about something, like our faces are symmetric. So if you think about somebody's face, the left side mirrors the right side pretty well. So we would say our face is semi-symmetric. Now we're going to talk about a couple different types of symmetry today: x-axis symmetry and y-axis symmetry. We say that something has x-axis symmetry if it can be reflected across the x-axis. So here is the x-axis. So if I think about something like, let's look at a graph like this. Now we're going to talk about this. This isn't actually the graph of a function, but this would have x-axis symmetry because you see that here, let me use a different color here. If we mirrored this side matches up with this side over here. If I fold it across the x-axis, it's symmetric. So that's how we would find it graphically, is we would just graph and see if we folded this up on the x-axis, does it match up? Now, how we would find that algebraically is a little bit different. How we would find that algebraically is we can see that if we have a y up here, that we're going to also have an equivalent negative y. So you replace y with negative y and simplify. If we get the same thing on both sides after we plug this in, this would be symmetric. So let me give you an example of that. Let me clear this out. So this is actually the equation for a circle, but it says replace y with negative y and simplify. So that's what we'll do here. So that's what we mean when we say test for symmetry. When I plug this in, what is negative y times negative y? Well, negative y times negative y is going to be a positive y squared. So this would be x squared plus y squared equals 1. That's the same thing we started with. So we would say, yes, this has x-axis symmetry. So what is y-axis symmetry? Well, it's the opposite. If we look at a graph, something has y-axis symmetry if we could fold this up on the y-axis and they match up on either side. So you can see this left-hand side mirrors what's on the right-hand side, so this has y-axis symmetry. How do you find it graphically? Well, you would just see if it folds up on the y-axis. How would you find it algebraically? Well, this time you're going to replace x with negative x and simplify. So let's try this with the same thing we just had, this equation of a circle. So we're going to replace x with negative x here. So it's going to be parentheses negative x squared plus y squared equals 1. What is negative x squared? Well, that's negative x times negative x, which is positive x squared. So I get x squared plus y squared equals 1. And again, that's the same thing. So we would say, yes, this has y-axis symmetry. Okay, so let's try a few of these. It says, does q of x, which is equal to x cubed minus x squared, have x or y-axis symmetry? If so, please show algebraically. So let's break this into two different cases. Hold on a second. I'm going to hit pause and give myself a little bit more space. All right. So again, I would do this on a piece of scrap paper, but let's do x-axis symmetry first. Remember, for this one, we replace y with negative y. So I'm going to take this equation. Now, I don't see a y. Remember that we can replace this q of x value with y. So we get y is equal to x cubed minus x squared. Now we're going to replace y with negative y. So we get negative y is equal to x cubed minus x squared. And if I divide both sides by negative 1 to try to get that y by itself, what I get is I get y is equal to negative x cubed plus x squared, which that is not the same thing, is it? So we would say no. No x-axis symmetry. Let's try y-axis symmetry. Well, we're going to plug in negative x. When we do that, it's going to give us, sorry, I'll put the y in there. Y is equal to parentheses negative x cubed minus negative x squared. Now, negative x cubed is negative x times negative x times negative x. Negative times a negative is going to give us a positive x squared times negative x is negative x cubed. So we get y is equal to negative x cubed minus, and then negative x squared is going to be a positive x squared. Is that the same thing we started with? So this would be no y-axis symmetry. So does it have x-axis symmetry or y-axis symmetry? The answer is no. And I can't graph this on the calculator, but let me pull up a GeoGebra graph of this, or a Desmos graph, and we'll see what this looks like. So I'm going to put this in, q of x equals x to the third, and then minus x squared. And when we take a look at this, you can see we can't fold this up on the x-axis, can we? And we can't fold this up on the y-axis either. So this has neither x nor y-axis symmetry. This one says, does x to the fourth minus x squared have x or y-axis symmetry? Why don't we start with a graph here and see if it has either. So I think it was x to the fourth minus x squared. So when I take a look at this, let's see if it has x-axis symmetry. If I look at a point up here, does it match up down here? No, I can't fold this up along the x-axis and have it match up. But when I look along this y-axis, I can see it does match up along the y-axis, doesn't it? If I have a point over here, it matches a point over there. So I'm pretty sure, or I'm very confident that it doesn't have x-axis symmetry, but it does have y-axis symmetry. So let's show that it has y-axis symmetry. How do we do that? Remember, it's kind of the opposite. For y-axis symmetry, you plug in a negative x. So I'm going to replace that q of x with y, and then we're going to put a negative x to the fourth minus x squared. Whoops, sorry. Minus parentheses negative x squared here. Now when I simplify that, negative x to the fourth is negative x times negative x times negative x times negative x. I can do these. Negative x times negative x is positive x squared. And over here, negative x times negative x is positive x squared. And x squared times x squared is x to the fourth power. So I get x to the fourth here. And we've simplified negative x squared a couple times. Negative x times negative x is positive x squared. And you can see that we get the same thing that we started with. So we would say yes, y-axis symmetry. Now, to show that there's not x-axis symmetry, we just put a negative y here. We can divide both sides by -1 to get the y by itself. And we get y is equal to negative x to the fourth, and then negative divided by a negative is a positive x squared. And that's not the same thing that we started with, so no, we would say there's not x-axis symmetry.